Okay, so today we'll discuss about the resistor in series and resistors in parallel. Okay, so resistors in series and parallel combination. Okay, so what will be the equivalent resistors if you will connect the resistors in series and if you will connect them in parallel? Suppose in a circuit the resistors are connected in series. Okay, let's say this is the symbols of resistors. Suppose these resistors are connected in series. Let's say the resistor R1, this is R2, and this is your R3. So this is your three resistors, they are connected in series. Let's say a potential difference or a battery is connected to them having voltage V. Okay, so this is the combination of series. So first we will calculate the equivalent resistance for the series combination. As you can see here the resistances are connected in series. So in series connection there will be potential drop across each resistor. Across each resistor there will be some drop in potential. Okay, let's say these drop in potentials are V1, and here the drop in potential is equal to V2, and here the drop in potential is equal to V3. And you know that potential difference is equal to, from Ohm's law, V is equal to I into R, the current flowing through the circuit into resistance. Okay, V is equal to I into R, you know. Now, so how much the potential difference will be here in V1? So here, suppose the current I is flowing here in the circuit, then I into R1 will be the potential drop across R1. And you remember, if there is no branching, so there will be the current same I will be flowing in every place. Okay, so we can write, and another thing is this voltage drop, the voltage drop, this is V1, V2 and V3. So all the sum of all the voltage drop will be equal to the net potential difference in the battery. So from here we will start our discussion. Let me erase. So here we are discussing about your resistors connected in series. Now you see. Okay. So the total potential difference V will be equal to sum of all the three potential difference, that will be V1 plus V2 plus V3. What is V1? V1 is equal to I times R1 from Ohm's law, and V2 is equal to I times R2. And what is V3? I times R3. I is same current will flow through each resistor because it is a single wire. If there is no branching, there will be no division in the current. Same current will flow throughout the circuit. Okay, V is equal to, now this total voltage, the total output in the source, that is V, potential difference V, so that will be equal to I times the total resistance. Okay, so this total voltage is equal to, or the source voltage is equal to, I times the total voltage, that is total resistance, that is R equivalent in the circuit, means total resistance offered by the circuit, that I'll write R equivalent. R equivalent is the net resistance, total resistance in the circuit. Okay, so now we'll simplify it. Let us erase this diagram. So here now you can easily do it. You can see in the left side, in the right side, I will be common. Okay, I will be common, R1 plus R2 plus R3. In the left side, I into R equivalent, I is same, both side cancel out. So what is R equivalent? R equivalent or total resistance offered by the circuit will be, in the series connection, will be sum of all the three resistance, will be sum of the all the resistance connected in series, all the resistors connected in series. So here we have taken three resistors, that's why its R equivalent will be R1 plus R2 plus R3. If we will generalize it, if there are n resistors connected in the circuit, then what will we write? If there are n resistors, then R equivalent will be R1 plus R2 plus R3 plus dot 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 plus Rn. If there are n numbers of resistors are there in the circuit, for n resistors, okay, for n resistors, R1 plus R2 plus R3 up to Rn. So this is the result for your resistor in series. Okay, so now we will calculate the resistors in parallel. Similarly, similar process we will follow and we will calculate the resistors in parallel. So let us proceed. So how will you, first let us draw the diagram for that. Let me erase it. So resistors in parallel. How will you connect the resistors in parallel? So now the resistors are connected in parallel. Parallel connection means the terminal of all the resistors will be same. So you can see all the three resistors are connected to their ends are connected to same 2 points. Let's say A and B. Okay, so that we will say this R1, R2 and R3, all the three resistors, they are connected in parallel. This is the way of connecting the resistance in parallel, because their ends are connected to same points. Such type of situation we will call resistors in parallel. Okay, after this discussion, in the next video I'll discuss about, I will solve some problem based on series and parallel combination. So here you can see the resistors are connected in series, in parallel. So we will calculate the equivalent resistance, the total resistance offered by the circuit. Now all these three resistors, let's say it's connected in a circuit and connected to a battery or cell, a single bit, your cell means okay. So now as you can see in this longer line is represents your positive and the shorter line represents the negative one. So it's a cell, combination of cells are called battery. Okay, so now the current will flow, the direction of current, that is the conventional direction, that will flow from positive to negative. Okay, so this will be the direction of current, let's say. So now suppose I current is flowing in the circuit, let's say I current will be flow and will flow in the circuit, and the source voltage, let's say, is the V. Now this current will come in same amount of I will come, but as I told you, if there is a single conductor, there will be no division of the current. Okay, if there is a single conductor, then there will be no division of the current. But if there is a branching in the circuit, the current will gets divided. So here at this junction, the currents will get divided, that will become I1, I2 and I3. Three different current will flow in the three different your branch. Okay, but remember, in parallel case the voltage remains same. Experimentally also it's verified that in parallel case, if the resistors are connected parallelly, then the voltage across each resistors remains same. How do we connect the voltmeter in a to calculate the resistance? We connect the voltmeter in the circuit parallel connection, and the ammeter we connect in a series connection. Anyway, so now as I told you, the in parallel combination, remember the same voltage will remain same, voltage will not change. Okay, only the current will gets divided. Okay, and you know the incoming current, that is I, will be equal to the sum of all outgoing currents. Okay, that also we'll learn in Kirchhoff's law in other chapter. Okay, the sum of all incoming currents is equal to sum of all outgoing currents. The current will not, means this current will be divided into three parts. Okay, depending upon the resistances, not always equal. So what will begin with, your total current will be equal to I1 plus I2 plus I3. In the first case, that is in series case, we have started the discussion, that is the total voltage is equal to V1 plus V2 plus V3. But here we have started the discussion, that is total current is equal to I1 plus I2 plus I3. Okay, so now what is I1? From Ohm's law we know that V is equal to I times R. This is Ohm's law. So now what will be I? I will be V by R. Okay, now in all the three resistors same voltage is there. Okay, but resistances are different. So how will you represent them? So I1 will be your voltage by R1. What will be I2? Same V by R2. What is I3? Same V by R3. So what will be the I? In the left side, I is the total current. So what will be the I in terms of V and resistance? So I will be the total voltage V, the source voltage, divided by the total resistance offered by the circuit, that was R equivalent or R total. Okay, now let me erase the diagram. So you can see here that what we got, V by R equivalent, that means V by R equivalent is equal to what we got, V will take common 1 by R1 plus 1 by R2 plus 1 by R3. Right, now V will get cancelled, same voltage. So now this equation will be 1 by R equivalent which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this is your, it is this side one. So this is the result for if resistors are connected in parallel. Okay, if the resistors are connected parallel, then what will be the total resistance? 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the diagram that we have erased. So three resistors, they are connected. If they are connected in series, then what is the result? 1 by R1 plus 1 by R2 plus 1 by R3. If instead of these three resistors, if there are n number of resistors are there, like R4, R5, n number of resistors you have connected in parallelly, then what will be the result? The result will be, if n number of resistors are connected parallelly, then the result will be, we'll generalize this equation. Just generalize means we will extend up to n resistors. So the equation will be, the final equation will be 1 by R equivalent or R total will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. First we have started the discussion with three resistors, then we have generalized the formula for n resistors, n number of resistors. n number of resistors. Okay, so today what we have discussed, two things. One is if resistors are connected in series, and the second one is if the resistors are connected in parallel. If the resistors are connected in series, then the result will be just the sum of all individual resistances, that is R equivalent will be R1 plus R2 plus R3 up to n number of resistors. How many number of resistors are connected depends upon that. Now if the resistors are connected in parallel, then we found that the result will be 1 by R equivalent will be 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this derivation is important both for class 10 and 12 intermediate students, and for the students who have just started the current electricity in the beginning level. Okay, thank you for watching this video. So maybe in the next video I'll discuss some problems. Very important questions are there, so I'll discuss some problems based on series and parallel combination. Thank you.